Okay, so hopefully this is working. Basically, I went and I marked up the picture that you sent me, and so I'll kind of just go over the different things that I wrote in and explain how this system works. Not sure what you already understand about it, but I'll just kind of start from the most basic stuff. Basically, this is like your circulatory system, but super simplified. So all that we have here is the heart in the middle, and then this upper portion right above it is the pulmonary circulation. So these are the blood vessels that connect the heart to the lungs. And then underneath the heart, we have systemic circulation. So the vessels that connect the heart to all the rest of the body. So your organs, muscles, anything else in your body that needs blood, basically. And so this diagram is showing essentially how gases are exchanged, similar to the way that, like we talked about it earlier today, how gases are exchanged in the lungs through the alveoli and the blood vessels, and how it travels through the circulatory system down to the tissues eventually, and how the gas is then, like the oxygen is um, diffused into the tissues, and CO2 diffuses from the tissues out into the blood vessels again. So we'll go over each of these kind of components and talk about the reasons why the gases diffuse in the way that they do. And hopefully that'll kind of give you a decent understanding of what's going on. And if you have any other questions, feel free to just shoot me a follow up email or something, and I can just clarify anything that doesn't make sense. So, to start with, uh, we'll start, I guess, from the heart and just follow the blood through this pathway here. So we'll start on the right side of the heart, down here in the right ventricle, which is this bottom chamber here. The blood here that's blue on this left half of the diagram, this is deoxygenated blood. So it's blood basically that has less oxygen than it does CO2. So you can see over here in this chart, since the bar for the O2 is lower than the bar for CO2, that's just kind of showing you that there's less oxygen and there's more CO2. And the actual numbers for the pressures of these gases in the blood are given right here. And I wrote them a little bit bigger on the side since they're hard to see in the picture. But basically, O2, you have like 40 millimeters of mercury, and CO2 is 45. And we'll talk about all these numbers in a second. So the blood travels from the right ventricle of the heart through the pulmonary artery. And an important thing to note here is the difference between arteries and veins. So, as I've written up here, arteries are blood vessels that run away from the heart. So I remember, like, artery starts with an A, right? And away starts with A. So that's how I remember that. That's what arteries do. And then veins run towards the heart. So I remember this just because, like, the Spanish word venir, like to come, I think of like the blood is coming towards the heart, or the blood vessel is going towards the heart. So that's how I remember this. If you want to remember it that way, you can, or if you just want to know that veins don't start with A, so they're not going to be running away from the heart, that works too. Um, so we have the pulmonary arteries that run away from the heart, and they go first here in the lungs, where they turn into these capillaries, like we talked about, on the alveoli. And if you remember, we talked about how in the alveoli, oxygen gas diffuses from the air that you inhale into the blood vessels, into the capillaries, and the CO2 diffuses out of the capillaries back into this air. And then in the lungs, you inhale, you exhale. And so you get that exchange of gases. You're kind of always refreshing that gas that is inside your lungs with the air that's outside. So, um, the reason, like we talked about, also that the CO2 diffuses out is because there's a higher pressure of CO2 inside the capillaries than there is outside in the air. And so this diagram here shows the, like, relative pressures of oxygen gas and CO2 gas in the air. And what you'll notice is the O2 gas is way up here, super high. So you have a high concentration, a high pressure of oxygen in the air that is just around you that you're breathing. And the CO2, you can't even really see how much CO2 there is in there because it's such a small fraction of the air that's around you. So if you remember, like we talked about also, gas wants to move from a place of high pressure to a place of low pressure. And in this instance, the place of high pressure is going to be the pulmonary artery right here. And the place of low pressure, where the CO2 is going to want to move, is going to be just the air in the lungs. And so that's why it moves out. And for a similar reason, the O2 is going to move in because there is a lower pressure of O2 in the air than there is in the capillaries right here. So oxygen gas moves from low to high into these capillaries, and then on the other end of the alveoli, the capillaries come together and they form the pulmonary veins. So the veins, they go towards the heart. This diagram shows the pressures of oxygen and CO2 in the veins, or the pulmonary veins. And we're on the right side of this diagram now. This blood, they mark it in red, and that means that it's oxygenated now. So you'll notice there's more oxygen in this blood than there is CO2, which is different than this other diagram over here, right? So basically, this oxygenated blood travels from the alveoli down to the heart, and then the heart pumps it down to the tissues. And then this diagram also here with the numbers tells you the pressures of O2 and CO2 in the blood that's on this half of the diagram. So 100 millimeters of mercury of oxygen, 40 millimeters of mercury of CO2. And then in the tissues have a lower pressure of O2 compared to the systemic arteries, and so oxygen is going to diffuse out of the systemic arteries and into the tissues, moving from low to high pressure. My bad, I misspoke. High pressure to low pressure. I might have misspoke earlier too when I was talking about oxygen up here. If I did, it's moving from high pressure to low pressure. So oxygen gas, similarly, is higher pressure in the tissues and lower pressure in the veins. And so as it's passing through the tissues, that CO2 gas then gets diffused into the blood. And you'll have the numbers here for that as well, as you can see. And then it basically just travels back up through the systemic veins to the heart. So I think the key thing to understand here is just looking at these numbers for the partial pressures of each of these gases individually. And I'll just start just talking about the oxygen. So when the blood first becomes oxygenated, it has a really high partial pressure of O2, right? When it moves down to the tissues and all that O2 gets diffused out, the partial pressure of oxygen in the tissues is 40 millimeters of mercury. And what you'll notice is the blood that's coming out of the tissues when it goes into the veins also has a partial pressure of 40 millimeters of mercury. So essentially what's happening is, since like the blood starts really high in the pressure of O2 with 100 and then diffuses out O2 until it is in equilibrium with the pressure in the tissues. And so that's why the blood ends up being 40 millimeters of mercury of O2, just the same as the tissues are 40 millimeters of mercury of O2. And this is good because then your tissues can use the oxygen, and then they can likewise get rid of CO2, because here the CO2 pressure is 40 millimeters of mercury. So it's lower than what it is in the tissues where it's 45. So it's going to move from high pressure to low pressure. You kick out the CO2 and it goes here into these veins and you'll notice the same trend where it moves up from 40 to 45. So it'll be in equilibrium with the amount the pressure of CO2 that's in the tissues. So that's why we have 45 here too. So basically, the 40 and the 45 that we see over here is exactly the same as what we see here, because the partial pressures of the gases in the blood are becoming in equilibrium with the partial pressures of the gases in the tissues. So hopefully that makes sense. If not, let me know and I can try to explain it a little bit better. But basically, this just continues in the same cycle. And the CO2 that the blood picked up from the tissues ends up running back through the heart, going back out to the lungs, gets diffused out, and we breathe it out, and just keeps repeating. So I think that's basically all the key information from this that you showed me, and hopefully it's helpful. And yeah, if not, just let me know, and I'll try and help you again. Thanks.